In this video, we're going to introduce the basics of how to write both two-column and paragraph proofs. If you'd like a refresher on the definition of a proof or related vocab, check out our video that's linked in the description. All right, we're going to go through a simple line segment example. First, we'll look at how to write a two-column proof. Then we'll use that same example and write a paragraph proof for it. Here's the information that we're going to be working with. We have our given information, also called the hypothesis, and the statement that we need to prove, also called the conclusion. What we need to do is provide step-by-step evidence that shows how to get from that given info to that statement we need to prove. A common question that comes up here is, how do we know that that conclusion is actually correct, that statement that we're proving? When it comes to mathematicians and researchers, they don't actually know whether it's correct or not. For them, part of working through a proof is actually determining whether a statement is true. But when you're in class, you don't need to worry about that. The statements that you're going to be given have already been proven to be true. The purpose of learning how to do the proofs is for you to develop your mathematical thinking and logical reasoning skills. So this is our situation. We're given that point S is between point R and point T. And we're also given that line segment RS is congruent to line segment ST. And we're told to prove that the length of RT equals 2 times the length of RS. So twice the length of RS. First, let's go ahead and make a model of all of this to help us organize the information that we're given. Here's a line segment that has point R on one end, point T on the other end, and S is between them. Next, I'll add in the congruence marks to show that RS is congruent to ST. Now let's get started on writing out that two-column proof. So as you'd expect, we're going to have two columns. The first one is going to be labeled statement, and the second one is going to be labeled reason. In the statement column, we're going to have all the mathematical steps that we're taking to show that the conclusion is correct. Then in our reason column, for each of those steps, we're going to give the reason that each step is mathematically allowed. The first statements that you put down are always going to be your given information. So you could have one piece of given information or several. In our case, we have two, and we're going to list them in order. And then for the reason column for each of these, we just put given. So for our first step, our statement is going to be the point S is between point R and point T. Reason is given. Step 2, our statement is that line segment RS is congruent to line segment ST, and our reason again is given. Now is when we have to start determining the next steps on our own. So for step 3, let's put that the length of RS is equal to the length of ST. You might be thinking, well, we already know this is true since they're congruent. But when you're writing a proof, we can't just automatically assume that something is true. We need to list every detail. And then something that definitely takes practice when you're writing proofs is getting used to saying things in a formal way when it comes to writing down the reasons. Like in this case here, we wouldn't just put down our reason as congruence. We would say the definition of congruent segments. Writing things out like this takes a little practice, but it can also help if you make a formula sheet with algebra and geometry properties that you've learned or any that you come across as you practice writing out proofs so you have them on hand the next time you work on something. And you can also look things up whenever needed when you're working on homework. Next, when we look at our model here, we can see that RT is made of two smaller segments, line segment RS and line segment ST. So what we'll put down next is that the length of RS plus the length of ST equals the length of RT. And our reason there is going to be the line segment addition postulate. When we learn the line segment addition postulate, it starts out with having AB plus BC equals AC. But remember, the A, B, and C are just placeholder letters. We replace them with the letters that are relevant to our situation, to our model. So the letters aren't what matters. The structure of the equation is what matters. So as long as you have all the parts equaling the whole thing, you're working with the line segment addition postulate. Now, looking back at step 3, we have that RS equals ST. So now what we're going to do in our equation here is we're going to replace ST with RS. And we're going to do that since the statement we need to prove is written in terms of RS and RT. Step 5 is going to be RS plus RS equals RT. And our reason there is the substitution property of equality. And that's a property that comes from algebra that tells us we can substitute things when they're equal. Now for step 6, we're going to add the RS and RS, combine those like terms we get that 2RS equals RT, and our reason there is simplification. Some instructors might be okay with writing down combining like terms, but simplification is kind of the bigger term that you use when you do those kind of things. At this point, we've already proven what we need to prove because 2RS equals RT is equivalent to RT equals 2RS. But if needed, you can go ahead and add one more step to specifically show that. So we could have a step 7 that says RT equals 2RS, and the reason for that is the symmetric property of equality. That's the property that tells us we can flip things around on an equal sign, that they're equivalent both ways. Okay, at this point, our 2-column proof is complete. Now let's go ahead and write this same example out using a paragraph proof. So we're going to have the exact same steps and the same reasons, but we just put them into sentence form. Since we're writing things out as paragraph, there's many different ways they can be written, but here's one example here. Since it's given that point S is between point R and point T, the line segment addition postulate tells us that the length of RS plus the length of ST equals the length of RT. We're also given that line segment RS is congruent to line segment ST, and from the definition of congruent segments, RS equals ST. Using the substitution property of equality gives that the length of RS plus the length of RS equals the length of RT. Simplifying, 2 times the length of RS equals the length of RT, which is equivalent to the length of RT equals 2 times the length of RS by the symmetric property of equality. All right, both of these proofs use the same reasoning. The only difference is the format. So 2-column proofs organize each step above and below each other, while paragraph proofs explain things in sentences. It's actually quite useful when you're writing a paragraph proof to go ahead and make the 2-column proof first, like on scratch paper, and then use that as a checklist when you're writing out your paragraph to make sure you don't miss any information. But the thing that will probably help you out most with the proofs is just kind of reviewing some of the properties from algebra, and then make sure that you're making a good note sheet or a formula sheet with everything, all the properties, postulates, definitions, theorems that you're learning as you move along in your geometry course. More examples of proof questions will be added to this geometry course playlist as we cover newer properties in geometry. And then in our next video, we're going to start talking about what angles are and how they are measured.